Jai Hind everyone. My name is Manoj Kumar, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. My today is theory of automata and formal language subject. Topic is minimization of DFA. DFA minimization. So what is DFA? DFA, deterministic finite automata. It is use a 5 tuples. First is set of state, capital Q, set of state, capital Q, set of state, capital Q equal to Q0, Q1, Q2 up to, and set of input symbol, non-empty set of input symbol, and third is transition function, and fourth is initial state. Q is a initial state, always one, only one, and capital F, set of final state. Capital is F is equal to set of final state, set of final state, F subset of capital Q. F subset, first is set of state, and second is set of input alphabets, and third is transition function. Transition function means capital Q, set of state and input symbol, and after transition Q is a state, is a transition function, and Q0 is a initial state, and capital F is a set of final state, acceptance state. Draw a transition diagram, any DFA diagram. It is a DFA, deterministic finite automata. Q0 is a initial state and Q4 is a final state, and transition table is a Q0 and Q0 it is a present state and next state. Q0 is a initial state and Q4 is a final state. Q0 input A is the next state is Q1, Q0 next input B is a next state is Q2, Q1 is a initial state, input A and next state is Q1, and Q1 B next state is Q2, and Q2 present state and next state is Q1 as a input, and Q2 is a present state and next state is Q2, Q3 is next state Q1, and Q4 is a final state Q1 and Q2. Step number first step is divided into two set of state. First is a set of non-final state. First is a set of non-final state, and second is a set of all final state. Set of all final state, and equivalence of the theorem, set of state Q0 P0 equal to Q0, Q1, Q2 and Q3, and next Q4. It is a non-final state, and Q4 is a final state. Step number third, partition of P1 equal to set of non-final state Q0, Q1, Q2, Q3, and Q4 is a final state. Partition is set number 1 and set number 2, and second is a P2, partition P2 equal to Q0, Q2 and Q1, Q3 and Q4, Q0, Q1, A input, Q0 and as a input A, Q1, Q0, Q0 and Q1, set number 2, and as a input Q0 and Q1, B input Q0 and Q1, B input Q2, Q3 is a set number 2, Q3 set number 2. This is a only one set of the partition. So Q0 and Q1, Q0 and Q2, Q0 and Q2 is a one set, and Q1 other set, Q3 is a other set. It is a Q0, Q1 and Q3, Q1 and Q3, A input Q1 and Q3 is A input, is a partition set number 2, and Q1 and Q2, B input set number Q1 and Q3, A set number 2 and set number this is a not a only one set, only one set, and Q0, Q1, Q3, Q0, Q1, Q3 and Q4 is a P3 equal to Q0, Q1 is a one set, Q0, Q2 a set number 1, and Q1, Q3 also different set, Q1 other set and Q3 is other set and Q4 is a other set. First set and second set number, third set number and fourth set number. Again try the partition of the set Q1 and Q3, as a input A, Q1 and Q3 as a input A, Q1 and Q1 is a set number, Q1 is a set number 2 and Q3 as a input A, Q3 and input A set number 2 and Q1 as a input B, Q1 and input B, Q3 set number 2 and Q3 as a input B set number 1. This is not a set, it is a partition. The Q1 and Q3 are a break the set, and P3 equal to P2, we stop the partition. P3 is a equivalence of the set, merge together. The Q0, this is a transition diagram, state transition diagram, Q0, Q3 is a one state, Q0, Q2 as a input B self loop and Q0, Q2 as a input A Q1 and self loop is a Q1 and Q0, Q2 as a Q4 as a input B a Q0, Q2. This is a minimization of DFA. Second example, problem number 2. It is a deterministic finite automata DFA, and first P naught equal to set of final state. Set of final state is a Q1 and Q2, and second set is a set of non-final state Q naught, Q3, set of non-final state, set number 1 and set number 2. Set number 1 and set number 2. Q naught, Q1, Q naught as a input A, set number 1, Q2 as a input A, Q2 as a input A, set number 1. It is a same set. And Q1 and Q2, Q1 as a input B, Q1 and Q2, Q1 as a input A is a Q2 is a set number 1, and Q1 as a input B, it is a Q1 set number 1. It is a same set Q1 and Q2. Q0, Q3 as a input A, Q0 and Q3 as a input A. Q0 as a input A is Q1 first set, and Q3 as a input A, Q1 it is a first set, and Q0 Q3 as a input B, Q0 as a input B, Q0 first set, and Q3 as a input B, Q2 a set number 1. It is a second set. This is a transition table. Q naught as a input A, Q1, and Q naught as a input B, Q naught, and Q1 as a input A, Q2, Q1 as a input B, Q1, and Q2 as a input A, Q1 and Q2. Next transition table is a transition table. Q naught as a input A, Q1, and Q naught as a input B, Q naught, and Q1 as a input A, Q2, and Q1 as a input B, Q1, Q2 as a input A, Q1, and Q2 as a input B, Q2. Step number 2, it is a first step 2, divide into 2 sets. Divide all the state in 2 sets. First set is a set of non-final state. First set of a set of non-final state, and second set 2 set of all final state. First to set of P naught equal to P naught partition number 1 equal to set of non-final state, Q1 and Q2, and set of final state is Q naught, iterated by the P naught equal to P1 equal to Q1, Q2, and Q naught as a input transition Q diagram, state diagram, also known as transition diagram. Q naught as a input B is a Q naught, and Q naught as a input A, Q1 and Q2, Q1 and Q2, and Q1 and Q2 as a input AB, Q1 and Q2. The minimize the DFA, A as a input initial state, A equal to Q naught and B equal to Q1 and Q2. This is also the transition diagram. A, it is a initial state as a input B, next state is A, and A as a input A, next state is B, and B as a input A, next state is A, B as a input B, next state is B. B is a final state. B equal to final state, and A equal to initial state. A is a initial state. This is a minimal DFA, minimization of DFA. Other example, a state transition diagram, a state diagram. It is also a transition diagram. Q naught as a input 0. Next stage is Q1. Q naught as a input 1. Next stage is Q3. Q1 as a input Q naught, Q2, Q1 as a input 1, Q4, and Q2 as a input 0, Q1, Q2 as a input 1, Q4, Q3 as a input 0, Q2, and Q3 as a input 1, Q4, Q4 as a input 0, Q4, and 1 as a input 1, Q4. This is a two-step process. First is a first is a non-final state. First is a non-final state, and second state a set of all final state. Set of all final state. P naught partition number 1 is a Q naught, Q1, Q2 non-final state. It is a one set Q1, Q naught, Q1, Q2, Q3. It is a non-final state, and final state is a Q4, is a other set. And partition number 1 P1 equal to Q naught is a other set, Q1, Q2, Q3, and Q4 is a other set. And partition number 2 is a P2 equal to Q naught, Q1, Q2, Q3, it is a other set, and Q4 final state is a other set. The step number 3 is a transition table, and partition number Q naught a other set, and Q1, Q2, and Q3 a other set, Q4 also the other set. The P1 equal to P2, the final equivalence partition is a P1 equal to P2. Q naught set number 1, Q1, Q2, and Q3 set number 2, and Q4 set number 3. The minimization DFA transition state diagram. Transition state diagram. Q naught is a initial state. Q naught is a initial state as a input 0 1, 0 in 1. Next state Q1, Q2, Q3, Q1, Q2, Q3 as a input 0, and Q4 as a input 1, 0 1 as a input. Q4 is a final state, and QA equal to Q naught, and B equal to Q1, Q2, Q3, and C equal to Q4. This is a state diagram. Q A is a initial state as a input 0 1. Next state is B. B is non-final state as a input 1, and one input C is a final state as a input 0 and 1. This is a minimization of DFA. This is a minimization of deterministic finite automata. Thank you.